We all remember in CS 165 learning about separating our code into different classes, structures, and files to help our code be easier to understand. Layering is very similar to this. It is an architecture pattern of grouping similar and like functionalities together. This allows the different layers to communicate with each other, different clients and applications. In this presentation, we will be discussing the most common layers and what they are. Then we'll discuss the process of deciding on the number of layers needed and how to group like functionalities. Last, we'll talk about how these layers interact with each other. According to our research, the most common layers that are mentioned were the presentation layer, the business layer, and the data layer. The presentation layer is responsible for communication logic, user interface, and browser communication. Basically, this layer is all about how the data is presented and displayed to the user. The business layer is sometimes split into a persistence layer and a business layer depending on how complex the application is. The business layer includes anything that has to do with the rules of the business. Examples would be how to get the customer data or calculating values. In our LDS teaching app, an example of this would be how we get access to the members' information. That would be included in the business layer. The data layer is responsible with how the data is stored. So this would include the databases, the data structures, and the data connections. There are a lot of other types of layers out there that can be used depending on how complex the application is. However, all the other layers fall into these three sections. If you want to learn more, you can always look at the references in the reference page if you want to learn more about that.
So just as the other slides said, there are those three main layers, the presentation, business, and data layer. And these are really the minimum amount of layers that you want when you're looking at a software project. They are the most important, and they're going to be in any project that uses this layering technique. And so what you want to do is start off with these basic three layers and then add more layers, such as the application layer as an example, as needed. This will allow your project to be more streamlined. And the reason we add more layers is we don't want a layer to do too much. This goes back to the programming idea of function cohesion and coupling, where you want tight cohesion, and loose coupling, where you want one function to do one thing really well. And that's the same with these layers. You want them to do one thing really well. And you want them to communicate with each other, so the data layer shouldn't be talking to the presentation layer, it should go through the business layer. And this is to allow for a logical flow in the project.
When it comes to layering for a system or an application, it's important to know how your layers will interact with each other. The reason for this is to prevent circular references and cut down on the amount of dependencies that you'll have in those applications, so that the layers will work properly with each other as they go through the application functionality and processes. The first type of interaction is top-down interaction, where upper layers interact with lower layers, but lower layers cannot interact with higher layers. This keeps it in a hierarchical setup so that your application and its system will maintain functionality through that sort of leveling. The next type of interaction is called strict interaction, where all the layers are only allowed to interact with the layer directly below itself. This keeps it as a one-to-one type of ratio, or one-to-many, if you look at it in different perspectives. And this will keep a lot of issues out of the way, but sometimes may make it more difficult to do other things. And then the last one is a loose interaction that says higher levels can go directly to the level they want by skipping over other layers. It's important to note that this can cause an issue with raising the amount of dependencies while potentially increasing performance. So you have to trade off with either one in order to have a loose interaction work. But overall, interacting layers need to be consistent so that a particular model, whichever one you use, can go into the system or the application and ensure that the functionality is going to be consistent.